Hello, everyone, and I'm really glad that we still have an opportunity to get together. I know the last year has been a little bit strange, or a lot strange for everyone, and I hope we're all managing to be safe. I look forward to seeing everyone when we can get together. I am pleased to have an opportunity to talk a little bit about what I've been doing. But I guess before I do that, I'm going to get comfortable. And I'll have to admit, there's one thing I don't get about these whole, safety precautions, which is everyone seems to go around like sticking their masks down on their chin when they're not using them. What's the point of that? It's like awkward and uncomfortable. I find this totally works a lot better. But okay, seriously, getting on to what I've been doing in the last while. So there's a common topic that, Debian has served its time, that it's becoming obsolete, that we're being replaced by containers, by language-specific repositories, and by another number of things. And distributions have done what they needed to do and are becoming a thing of the past. And I talked a little bit about this in my keynote as DPL last year. But over the last year, Clete Dinez and I have been working on a project where we've had a lot of experience with all the different ways that people distribute software in the free software community. And as part of that, we've had a great opportunity to figure out what works well about these mechanisms and what works poorly. And we'd like to share that with you so that we can get kind of a better idea of what Debian's role might be going forward and how it works with all of these different systems. So what's the problem that brought us to this project? Well, governments have been working on improving cyber defense all around the world. And when governments come to critical infrastructure providers like utilities or banks and ask them, hey, would you like some help in case there's a cyber attack? The initial response is positive. Of course, then you get to the part where you say, hey, would you like our people to come onto your production networks and do some training exercises so they're ready to help you? Well, no one's actually silly enough to ask that question, because of course no one wants a bunch of people doing their training on production networks. It doesn't make any sense at all. So we need some way to do cyber defense training that's realistic, so that if there is an actual incident, people have the skills they need to actually help out these infrastructure providers. And so we've been working on building environments to do that. As part of that, we've been realizing that we need to virtualize the internet and virtualize the environments that these critical infrastructure companies will have so that people can train on them. So what we've done is we've created a system to do that. There are a couple of reasons we virtualize the internet rather than just virtualizing parts of the system that are appropriate to the training we're conducting. The biggest is to avoid a big oops if something gets out of the training exercise. It would be pretty bad PR if you had a situation where, some training is going along and then things get a little bit slow, and then there's you start getting news reports that some cyber training exercise ended up taking out a small country accidentally, or leaked over to a production network and caused a real incident. Secondly, and I think it's a concern that many people believe is important, but in practice is perhaps not as critical as it's made out to be on paper, is the idea that some of the defense techniques are things that we don't want the attackers to learn. In practice, if you want to learn cyber defense techniques, go to Amazon. Even cyber defense techniques for major governments tend to be available in books that are readily available on Amazon. For the US, you could start with the Blue Team Handbook by Colonel Alan White, easily available on Amazon, and it'll probably give you a good idea where the US was a few years ago. I mean, obviously there are parts of it that are secret, but for the most part, I think the real concern is to make sure that exercises stay self-contained. And yet, when we do virtualize the internet, we need to make sure that the training environment feels enough like the real thing that people can actually learn and gain their skills. So what did we build? We started off with a bunch of infrastructure as code VMs because we want to be able to fine-tune the system whenever we come up with different exercises and tune it for the exercise we're doing. But we also want to be able to improve and evolve the system over time. One of the big decisions we made early on is that we decided that we're going to build most of the environment from within itself. So at the beginning, when you're setting things up, there's an asset transition phase where things like a full copy of Debian, Kali, Ubuntu, and various other software get moved into the environment. But then from that point on, it's entirely disconnected from the internet. And the environment builds itself using resources entirely in the fake internet. So we start by building network infrastructure. Then we build the software distribution infrastructure to actually build out the rest of the VMs. And then, of course, we're going to build out the environments that we're going to train in. But of course, that all needs to be about against a backdrop of a useful virtual world. And of course, we start out with the best agro-space business you've ever heard of. And then we move on to a taste of home because, you know, the world wouldn't be worth it without a little bit of fun food to take advantage. And then, of course, we need payroll because no one's going to work in this environment if they aren't getting paid. And so we have the most trustworthy payroll company in the entire world. So what have we learned? We learned a lot about how software is distributed, and that's the primary focus of this talk. There are a number of ways that we're approaching software distribution in the free software community today. There's GitHub, and I realize that it's more than just GitHub. There's all sorts of different Git repositories. There's GitLab, all that sort of thing. But GitHub is special in its own way, whether we like it or not. GitHub is more than just Git. It's an entire ecosystem of how to approach CI, how to approach issue tracking and collaboration. There's repository-specific packages, and we'll be talking about those a fair bit. There's containers and Docker. There's distribution packages. And there's cloud images, and in the commercial world, OVAs. And we're going to talk about some of these. Unfortunately, we're not going to have time to delve into all of them. I could give a 45-minute talk on cloud images alone, and while that would be a lot of fun, that's not where we're focusing today. For each of these, we're focusing on a number of metrics to compare and contrast them. The first and kind of obvious metric is how recent is the version of software you're going to get from the system. You know, in Debian stable, it might be a few years old, whereas in GitHub, it might be so bleeding edge that it doesn't even build yet. Or from a repository-specific package, you might have the version that the developer decided this morning is ready for release and is something that you're recommended to use. The next area that we're going to consider is dependency management. In Debian, you have a requirement that all of the dependencies in an installation must be consistent and work together. So if I have library X involved at all the software needs to support the same version of library X. Whereas in most of the other systems we're going to talk about today, dependencies are managed per project. One project could use version 3 of library X, and another project could use version 2, and that's fine. The next factor is security updates. And this has a number of facets to it. Where do the security updates come from? Do I have to update to the latest version of the software to get new security updates? Or is there a mechanism that I can get security updates on a stable version of the software so I don't have to change what APIs I'm using just to get a fix for a critical security problem? The next factor is something I'm calling similarity of software from different ecosystems. And that's perhaps not the simplest bullet point to understand. But the point is that what happens when I've got software from Python, software from Ruby, you know, some things that are written in C, some things that are written in Rust, all in the same environment. Do the Python things look like Python things, or do they all look the same so that all the software presents a consistent interface. Debian did a lot of work in the beginning of its existence on its policy and trying to create uniformity. Whereas there are a lot of languages today that focus on consistency within the language and a clean experience there, even if consistency between the languages is sacrificed. And finally, we're going to think about replication without the internet, because as I did mention, we're building this whole thing without access to the internet. And so if the software requires access to the internet to install and build, well, that's not going to work in our environment. And that's something Debian has cared about since the beginning of its time, going back to the Desert Island test. Really going back further is the early versions of Debian were distributed on CD. And I mean, we still make DVDs available today. In fact, in our environment, we use those DVDs. And so it's something that is important in some environments, and it's something that people entirely ignore in other environments. The first software distribution mechanism we're really going to look at in depth is language-specific repositories. There are a number of examples that we've all come across. There's PyPy, the Python language-specific repository. There's Ruby gems. There's NPM, Node Package Manager for the JavaScript community. There's Rust, the cargo crate system, and then of course there's the Go, which I guess in that environment actually language-specific repositories look a lot like GitHub, or at least Git of some kind. There are huge advantages to language-specific repositories. The first is that it's quite clearly the most up-to-date, ready-to-use software. It may be that Git has something a little bit newer than the language-specific repository, but in terms of things that you can use and the developers recommend that you use, language-specific repositories are going to be faster than anything else. Language-specific repositories are easy for developers to use. They're built into the language ecosystems. They have good dependency management. Typically in all the language-specific repositories I'm familiar with, it is per project dependency. So it's okay if one project is moving at a different speed than another. And the language-specific repositories have very good integration within the language communities. One claim I've heard when talking about language-specific repositories is that with per project dependencies, where each project has its own version of the package, there's not really a good way of dealing with security. That's just not true. There's best practices have developed for approaching that. There are services. I point to one for Python, but there are also there's Dependapot on GitHub, which I haven't really researched, but Russ was talking to me about a few days ago, where the software will track whether the dependencies that your project is currently using are out of date. And if so, we'll give you a pull request to update your software. And then you have your continuous integration tests that will be run and triggered by that pull request or merge request. And we'll let you know if the new dependencies work on your software. And if so, then you can update things. And you can get the best of both worlds. You get up-to-date security integration of security updates, but you also know that the version of software that you're testing against and the developer recommends is consistent across the entire community using the project. Unfortunately, there are also some significant disadvantages to language-specific repositories. There's no third-party review of licenses. Yes, most of the language-specific repositories let you know what the license of the program is. And yet, as I think we're all too familiar in the Debian community, when you go to actually look into all the files in the repository, you sometimes find things where the source code is missing, or it's not really distributed under that license. There are a lot of packages where we end up adding DFSG constraints because upstream didn't meet our guidelines for free software. And if you value being sure that you have free software, being sure that you have source code, that third-party review can be important. There's no way to describe cross-language dependencies in most of the language-specific repositories. It's great if I have a whole bunch of Python components. But what happens whenever I want to go have a C library and I don't really want to repackage that C library as part of a Python extension? I may not be able to express that dependency. Or what about when my web application wants to go shell out to some application for image manipulation or something else like that? There's not necessarily a good way of expressing that. Security and trustability of a system is a mixed bag. I talked on the last slide about how it is possible to do security updates really well. It doesn't mean everyone does. We've seen cases where applications haven't taken advantage of security updates and where it would take API changes to do so. We've also seen examples where people introduce malicious code. There was an example in the JavaScript community where people introduced a malicious change into a dependency a few levels up in the stack just to get private keys out of a Bitcoin wallet. Just because the code is in a language-specific repository doesn't necessarily mean that you can trust it. The next big software distribution mechanism is Docker and containers. So how do they work? Typically, and we're going to focus in this talk on server-focused containers, so like Docker or other systems that are producing containers to run on servers. Much of what I'm saying is also applicable to Flatpak and Snap and other user-focused application containers, but not all of it. Typically, containers are built with some sort of recipe, typically by starting from other containers, or in some cases from an empty slate, and running commands and adding files to produce a container. Typically, those commands have access to the internet. So, for example, a very common command to run might very well be apt install. And this recipe is run and it produces a container, and then you can use that container. Containers are easy to package software that's complex, even if it crosses multiple languages. They provide a great solution to the problem we were discussing a few minutes ago of how to handle cross-language dependencies. Containers have good dependency isolation. Each container has its own set of software. And so it's totally fine if one container is different, has a different set of dependencies than another container. At least insofar as software that's entirely within the container. Things get a little bit more complicated in the Flatpak and Snap universe as you start looking at dbus APIs and that sort of thing. And you can get the same effect or same problem in a server container as you run across network services. Although, at least if you can keep things within your same set of containers, things can work pretty well. There are mechanisms for putting sets of containers together, like Docker Compose, or up in the larger, more complicated side of the things, Kubernetes, which allow you to build collections of services based on containers. Containers provide a really easy way to approach software from any environment that you can just install and start using. Other people's containers are great, at least so long as you can treat them as a black box and don't need to look inside. But sometimes, because you're debugging, or because you need to integrate it with your environment, because you'd like to make some downstream change, you need to look inside the containers and treat them and take a look at what's inside. And unfortunately, whenever you do that, you're going to find something that you don't expect. I mean, who would put Aperol in a fridge? But when you look inside someone else's container, it's going to be like that. You're going to have to figure out the individual quirks of that particular environment and deal with them. And that brings us to the more general disadvantages of containers. Like everything else we've discussed so far, there's no independent review of licenses or of the trustworthiness of the software. And that can be a particularly big issue on containers because it's very common to find, even when the software is supposed to be free software, that little bits got snuck in to make things work easily, where there's not source code or where it's not free software like you expected. Secondly, it's very hard to tell what software makes up a container. Yeah, I know there are metadata proposals, there are tools to help with this. We're working on the problem as a community. But if someone gives me a blob container and says, hey, what's in there? What operating system is it? What software is on it? What language-specific software has been installed? That's actually really hard to answer. And then, when it comes time to rebuild a container so you can make a change, that might not work so easily. Why is building a container hard? Well, starting out, you might not necessarily have the recipe. Just because the recipes can be provided doesn't mean that they will be. Even if you do have the recipe, it probably depends on internet artifacts. You might use apt or some other package manager to download things. And so when you run it, you might get different results. It might not work. It might get newer versions of dependencies. Or things might have changed and you might get a 404 and it might not work at all. You don't necessarily have a lot of options in that choice. You do have a couple of options if rebuilding the container isn't going to work. You can take the container as a starting point and apply changes to it. And for some things, that might work fine. But in other cases, you really do need to be able to rebuild the container. Again, this is a case where it's quite possible to do things right, quite possible to do things in a reproducible manner that preserves user freedom. But not everyone does. And that brings us to distribution packages in Debian. And we're going to start off with the disadvantages, because there are some really big ones. Even Debian, with its 30,000 source packages, and Debian's pretty big, is it only packaging a small fraction of the free software that you might want to use. Stable distributions can be years out of date. Okay, so unstable is going to save you. Well, sort of. But even with unstable, the fact that we've chosen to lock all our dependencies together so that all our dependencies need to be consistent means that transitions can slow down your ability to include new software or to update the versions of software. And those are some fairly big disadvantages. The security support that Debian or a distribution provides may not be as good as the security support provided by the best of upstreams. Yes, our security team is great, and I'm not criticizing the security team. They have a really hard problem and they do a great job of it. And for some packages, they're actually going to provide a better security experience than the upstreams do. But for some upstreams that are really on top of the security issues in their software, the upstreams are going to provide faster security updates than we're able to do. Even so, in our environment, we choose to use Debian when we can. There are a couple of really important things we get out of it. We get a single interface for installing packages, even when they cut across multiple languages. And yes, we're going to have to use PyPy and all the rest, but we find there's real value from a sysadmin standpoint in using a consistent interface when you can. Debian makes it easy to provide cross-language dependencies so that we know that we have a package that spans multiple languages. We're going to get all the software we need. We also know that upgrades are going to work better because they're going to take into account the dependencies across languages as well. One of the big advantages we get out of Debian is that when we want to make longitudinal changes, like we want to change a base dependency and have that change reflected in all the software. That is to say, we want to use the freedom that free software is supposed to give us, and as a user, make a change. We know that's going to work on Debian. But there are some cases where we can't use Debian. When the software in Debian is too old, when our training exercise requires us to set up the software like upstream would, rather than like a distribution would, or when the software is not involved in Debian at all. One of the other important things to keep in mind when thinking about distribution packages is auditing and the distribution review. Debian provides a great service in verifying that packages meet the DFSG, that they're actually free software. It provides some review of whether software is trustworthy. Someone had to think it was worth sponsoring into the archive, and presumably thought about whether it involved malicious code. Debian is going to give us pretty high confidence that if we rebuild the package, if we want to make a change, if we want to exercise our user freedom, it's going to work. Pretty much all Debian packages do actually build from source. That's something we get right consistently. When you engage in a project like this, you're bound to learn something, bound to be surprised. And for me, that surprise was how big of a deal mirroring software without the internet became, how many complex interactions we ran into on that space. And I'm not talking about software that goes out to some CDN for JavaScript. I mean, yeah, that's a problem. It's actually a pretty big one, but it's outside of the scope of this talk. I'm simply talking about the challenge of mirroring software so that we can install it within an isolated environment. So the problem is that we need to install distribution software, portions of Docker Hub, and portions of language-specific repositories in an environment without the internet. So we need to be able to subset that software, copy it into our environment, and also duplicate any services that are required to access the software from its clients, like the language-specific software clients or the distribution clients. So let's take NPM as an example. If you go look at the NPM documentation, it says that, yeah, sure, you can run your own registry. It shouldn't be that hard. Here's a link to a mirror of our database, and here's a link to a mirror of the application you're going to need to run and install on GitHub. You know, it looks pretty exciting and not, you know, it's going to be big because NPM is big, but it shouldn't be that big of a deal. And then you go to that GitHub page, and the README starts off by saying that this software is unmaintained, is only a part of what you would need for a registry. This software no longer accepts changes, and we recommend that you go look at a bunch of API documentation that, mind you, doesn't have software you can run. It's just a bunch of documentation for the software that npm.com runs. Yes, there are third-party JavaScript node registry solutions. As far as I can tell, those are more targeted at companies that want to have a registry for their proprietary JavaScript than they are at providing an internet-isolated replica of some parts of the public JavaScript repository. It's possible to do, but it's kind of a huge mess. So even if the software you install is free software, it doesn't mean that all the services that you need to run it will be free software. Even if they are, even if you can find source code for them, it doesn't mean that that source code will be as easy to use as other aspects of the free software ecosystem. It's not run as often, and so it's going to be harder to set up and harder to use. And that makes mirroring software without the internet much more challenging than you might at first think it would be. And that's a really important concern for people who, for security or privacy reasons, want to isolate their environment from the internet. Debian does a lot of things right in this area. Debian provides access to a number of tools for mirroring Debian. It provides access to, you can do it with your own trust anchors, or you can use Debian's trust anchors depending on whether you're going to be making changes to Debian or whether you're going to be using Debian as it is. You can start mirroring Debian and get an architecture of Debian mirrored in a few hours and mirror the whole thing in a couple of days. Yeah, it's not small, but it's quite doable. Contrast that with Fedora, where using their tools, it took 2 days just to figure out the list of files that their software needed to download. Apparently, starting up a Fedora mirror, their algorithm for figuring out what's changed is a little bit more inefficient than you might hope for. That said, Debian has a couple of lurking problems that we probably want to think about. As Go, Rust, and other parts of the ecosystem start using static dependencies, it becomes more important for people other than Debian.org to be able to rebuild all those dependencies when they exercise their user freedom and make a change. Our tools for that could use better documentation, and I think that they might actually be a little bit specific to Debian.org. I'm not sure, but we should work on that and make sure that we have good documentation and good tools that third parties can use. That actually applies in general to some of the other tools. It is certainly possible to run a Debian downstream, and I think we do the best out of anyone in the distribution space at making that possible. But I think it's an area where improvement is still quite welcome. So what does this all mean for Debian? Well, let's start with what it doesn't mean. It doesn't mean that Debian has served its time and is irrelevant. It doesn't mean that Debian is going to take over all of these other software distribution mechanisms. All of these mechanisms have really important niches to play. They all form a vibrant free software ecosystem, and we need them all. What I think this does mean for Debian is that we need to be able to explain and advocate for our positions. We need to be able to help upstreams and our users and ourselves understand what Debian brings to the table, what our values are, what our limitations are, and where appropriate, work with other parts of the ecosystem and advocate for those values when it makes sense. Okay, so what are the values? Debian brings value in reviewing the licenses and supportability of software. The DFSG in that review is something that is really important. We bring value in providing a stable collection of software that users can use. We bring value in actually focusing on user freedom and providing processes that make it very likely that if users want to make changes, they're going to be able to succeed in making those changes. But Debian has some really big limitations. One of them is that because of our decision to have a consistent set of dependencies, it's inherently the case that the bigger Debian gets, the slower we're going to be at adding software to Debian or updating the versions of softwares in Debian. The value we bring to the table costs time and effort, and that's a cost. It's not necessarily something that people need for every package, everything out there. And finally, we're never going to be able to package all the software that's out there, not even all the software that we could package if we wanted to, according to our rules. How can we help the world? How can we advocate for those values? In working with upstreams, I think we can advocate for the importance of user freedom and work to improve people's ability to make changes in software and see that changes picked up by the things they build and be able to change dependencies and have those changes reflected in all the software that they want it to be reflected in. I think that we can work within our community and with the upstream communities to make it easier to package upstream software. And without giving up on things that are core to Debian, we won't be able to do away with review or the need to make changes sometimes. But we don't need to have our tools get in the way. The Rust team has been making great strides in this area, as I think have all of our language teams. But I think this is an ongoing area for improvement. And finally, we should pay attention to efforts that are looking at ways of doing distributions where the dependencies aren't locked together, where one package can have a different set of dependency than another. It's not that simple. Even if we could do it, we would need to still find a way of having good security support and having a good way to make things easier for our users to make changes. But I think focusing on those efforts and making sure we learn what we can will be valuable to us. thank you very much. I hope I have time for questions. And before I move on to that, I'd like to do a couple of thank yous to Cleodines for helping me put together this talk and put together the information for it, and for Matt Tinney for helping with the video and producing the actual talk. And of course to the DebConf team for their role in making this all possible.
So thank you for sharing your findings, Sam. I must add that the production quality was quite high with the video. So moving on, as there are no questions on the Etherpad, I'll quickly check the IRC for any questions. So let me just see.
Okay, while we're starting out, I would really like to echo, several people seem to have liked the video production. I would really like to thank my colleague Matt Tinney, who helped with that and basically put that together.
Oh, that's cool. Let me see. Clap. And so we have something coming up on the Etherpad. So let's wait for that. Oh, thanks, Sam. You're optimistic. So it says, the question says, thanks, Sam. Are you optimistic that we can do better across NPM and similar packages?
Well, I mean, it depends on what you mean by do better, right? I mean, I think in some level, we do a good job of supporting NPM, and that you can run NPM on Debian and you can go install any NPM package you want. And if you go look at recipes out there on the web for how people talk about using NPM, many of them talk about using it on Debian or Debian's derivatives. So there's a level at which we're doing great. Can we do better at making it easy to integrate new JavaScript packages? I think I argue that we provide, by doing the review and the auditing and looking at DFGSG issues, we provide a real service. So we're never going to be able to just automate without humans looking at things, all of the packages. Can we do continue to improve tooling so that it becomes easier? Yeah, probably. The Rust folks are doing some really interesting work in that way. I'm not following what the JavaScript team is doing. I do know that the Python team has gotten much better over the years. And so I'm sure that we can improve in that regard. Can we improve in handling things like at the new queue layer? Yes, probably we can do that too. And all of those efforts are underway. And if you want to participate, go find the relevant teams and volunteer.
Yeah, that answers it well. So let's move on to the next question. This one is not complete, so we'll skip over that for now. So another question says, would models like NixOS, GNU Guix potentially address some of the coin stability problems?
The what stability problems?
It says coin stability problems. I'm not sure what that is.
So I believe that what you're focusing on there is environments where each package gets its own set of dependencies. I think that's the relevant property of the operating systems you mentioned there. Yeah, I think that's really interesting. I think some of those systems give up user freedom, and that it's harder to make a longitudinal change and to sort of push it to all the subdependencies. I think that we could look at something like that and look at maintaining user freedom in such a system. But I still think we'd have to look at how we would do security support and stuff like that. I really think there's lots of interesting research going on. And when I talk about advocating for our positions and values, one of the things I think we can really contribute as people are looking at those models is to remind them that one of the things we care about is a user wanting to make a change to some base library and have it reflected against everything on their system.
Yeah, so it was co-instability. Now the hyphen is there. So let's move to the next question. It says, Sam, at the end you mentioned the REST team specifically. Could you elaborate on what you think they are doing better than Debian?
I mentioned what specifically?
The Rust team.
Oh, yeah, so Rust has, rather than having each package kind of be copied into its own Git repository, they have a central Git repository, which basically is focused on the differences from Rust. So basically, the amount of effort to package something for Rust is perhaps lower than for some of the language-specific teams, at the cost that their tooling looks a little less Debian than you might be used to. And yet, as I understand it, it provides all the flexibility we need. You can add a patch if you need to, is my understanding, for example. It's a very different way to look at things that seems to be working for them. And I think it's something to learn from. I mention it basically because it is so different from the rest of how we approach things.
Yeah, true. So another question says, do you have any idea how unlocking dependencies in Debian could work in practice?
I would recommend looking at the different operating systems mentioned in the previous question. There's also someone who blogs on Planet about I guess it's Distry,